Hey Eric, I'm not having much luck running the simulation on any of the web browsers, so let's try to find a way to answer these questions from the online simulation otherwise. Definitely if you wanted to find P waves versus S waves, we should start with P. A P wave is a compression wave. Think of it like pushing, and it's going to shake the ground back and forth in the same direction, in the opposite direction as the direction the wave is moving, which means that as the waves are traveling forward, the ground is going to be shaking back and forth, if you can see my wonderful illustration. And the opposite direction is just the force coming back against. So if it's moving towards the right, the force is getting shaken towards the left. So if you were looking for a definition, this might be a good place to pause it and grab this one if you want. So I was trying to understand what's the difference between a P wave and an S wave. And to me, it's about the motion that each of them make. And if you look down on this chart here, because P waves are going to move the ground back and forth in the same direction, you get a small jolt, light shaking. A lot of times you can't feel these, though animals can feel these if we're concerning earthquakes as well. And then you can see that S waves have a tremendous amount more of shaking of momentum as well. So when we look at an S wave, it's called a shear wave as far as what it stands for. And it shakes the ground back and forth, but instead of parallel or in the same direction, it's perpendicular. And so I'll show you an animation here in a second of those to the direction that the wave is moving. So at this point, it would be good to stop and write down your definition for your S wave. And I'll let Mrs. Reed know that you're using this website to do so. You could also get them from the back of your book if you really wanted, but I think either is fine. So that means that we're looking at P waves. You can see them moving through parallel to the wave motion. And then here we have the perpendicular motion. Almost like a right angle when you think perpendicular, like the letter T. The top part of the T is perpendicular to the bottom part. So definitely if we're looking at the type of seismic wave that's going to cause the most damage, it's going to be an S wave versus a P wave. All right, let's talk a little bit about the differences between these waves. And the question that you have right now is, what type of wave travels the farthest? And which one does have the most momentum between P waves or S waves? Okay, so here's what you need to know about P waves. P waves are going to be the first waves to travel, to get there the fastest, to arrive at a seismograph when they're testing. P waves are going to be what we see first. They're the fastest seismic waves. And as far as momentum goes, they can move through solid, liquid, or gas. This is going to be the type of wave then that's going to be able to travel the farthest. So that's your P wave. What type of wave is bent or refracted? And I think you can see up here the differences between the two as far as which wave is refracted. Question 3 says, guessing from the behaviors of the waves, how many layers of Earth's interior are there? What observation led you to your choice? And we don't really have that in the simulation, but if we take a look here, okay, of Earth's interior, mantle, the outer core, and the inner core, then you're going to want to select 3 for those. What observations led you to your choice? Since this is not working, I would like for you to tell her that you used a chart to do this. Okay. So now that you're taking a look here, and I'm using this to support my answer for number 3, you need to label the following layers of the Earth on the diagram right there. Keeping in mind that that crust is the outer layer, so that's why you have 4 when you don't have 4 layers. So if you want to take a look here, that's what you're going to want to use to label. This would be a good time to pause with the space bar if you want. As we head into some of these other questions about density and pressure and temperature, we can't really observe the simulation. So for number 5, it says, what type of wave goes through the Earth's center or the core? I'm going to play you some of these Quizlet flashcards that are going to answer some of these questions that are coming up as well. I did not make these, I just found them online. The outer core, if you need a memory jogger, is composed up of metal, liquid iron, and nickel. And that spinning outer core is what actually creates our gravitational field. The inner core's composition is listed here: solid raw iron and nickel. The inner core is the most dense portion of Earth. So that means that as you're traveling towards the interior of the Earth, that density is increasing. And then that would also be the pressure that is increasing as well. Seismic waves are one of the ways that scientists are able to kind of break down what might be inside the surface of the Earth. S waves, those can travel through the crust and it can travel through the mantle as well. So those aren't going to have maybe the force or the momentum as those P waves. Trying to see. So the pressure changes when you go from the surface of the Earth to the center of the Earth by increasing. Density should increase as well. Yep, I was right on both of those. Now, as far as the temperature goes, as you move from the surface to the center of the Earth, everything increases. So if you look at that chart, it's increase, increase, increase for your multiple choice. So that leaves number 11, which I think we know number 10 and 11. Number 10 is, do you expect the density of the mantle to be greater or less than the density of the core? And since everything is getting much more dense, what we can see with the S waves and the P waves is that the S waves are not going to be able to travel through the core because the density is too great. So however you want to word that for number 10. For number 11, would you think that the density of the mantle is greater or less than the crust? And I think there's a lot of good reasons as far as what we know about the crust and having a lot of air in it as well. But if it gets more dense the further towards the center you go than if you're working away from the center, then I think you can logically answer that question. Okay, let's take a look at these P waves traveling through the mantle, S waves traveling through the mantle. So here we have P waves, compression waves. They can move through solids and liquids. And then S waves can only move through solids and not liquids. That's not so helpful. We'll go one more slide. Here's the final simulation that I'm going to show you, Uric, and it's this P waves and S waves moving through the Earth's interior. So let's take a look and I'll read you what it says on the right while I continuously play this, and you can look at that. It says the simulation shows the motion of P and S waves generated by a single earthquake. The waves spread through the planet in a series of expanding spheres. Some of the wave energy reflects off the boundary between the mantle and core. Scientists deduce the structure of Earth's interior and how waves move through it by analyzing thousands of earthquakes recorded at Earth's surface. So if I'm taking a look at this dark blue line and I'm watching that P wave work its way through the mantle, or the outer core, not the inner core, right here. See, in that one it's moving all the way through. S waves are stopping pretty much when you get to the inner core, and the P waves are continuing.